of 2x cubed plus x squared minus 3x plus 2 and negative x squared plus 4x minus 5. What do you mean? What do I mean by find the sum? Add them up. So we're just combining like terms here. So 2x cubed, any other x cubes? So we still have 2x cubed. I'm going to cross them out as I go. X squared plus negative x squared. 0x squared. So we don't write it. Very good. Negative 3x plus 4x. Plus 1x. So I'm going to write plus x because we're advanced. We're going to write plus x instead of plus 1x. Positive 2 plus negative 5. Minus 3. How many of you got 100% correct? Awesome. Now this was an exact question that I saw on an end of level test. You would not miss it, would you? Okay, awesome. Let's go on. Okay, so today, once again, you should have learned this in secondary math 1. We're just going to do some more rigor today in secondary 3. So we're going to be solving systems of 2 equations today, which we're going to get into bigger ones later on in this unit. So we're going to be solving systems of 2 equations, and we're going to be solving linear equations today. Now understand, linear means degree 1. So if we're talking degree 1, it makes it linear. Now when we're solving a system of equations, it will look something like this. Y equals x plus 1, and then this is linear as well. 2x plus y is equal to 7. When we solve these things, now I'm going to show you what we're doing. When we solve these, we're finding the x and y value that makes the statement true, or where they intersect, where they are equal. So I graphed my red line. There it is. I graphed my purple line. Now to be able to graph the purple line, I put it in graphing form, right? So I would have subtracted 2x from both sides. And then is it in y equals mx plus b? So then I did that, and then I graphed it. So when we solve systems of equations, guys, we're finding the x, y that makes the statement true. In other words, where they intersect. Do you understand that? Okay. So there are 3 couple different ways of solving, and we're going to do all 3 today. Substitution, elimination, and graphing. Really, any method you want to use, you can use. We're going to practice all 3 today because sometimes one's better than the other. And honestly, some of them take more advanced thinking, and we're all about learning how to think advancedly in this class. So when we start out by doing substitution, I need you doing substitution. When we do elimination, I need you doing elimination. And then with graphing, it's probably the easiest. You just use your calculator. On an end-of-level test, I always opt for graphing if possible, because it's just easier. So you're going to see that every method's different. You might like one method better than the other. So let's start out by substitution. Every example is coming from your worksheet. So if you want to take some notes, go through this with me, that'd probably be good. So number 1, it says solve the systems of equation by substitution. So once again, we're looking for the x and y values that make this statement true, that make these equal at the same time, which means where they intersect. So we're doing it by substitution. So substitution means you focus on one of the 2 functions, you take that function and substitute it into the other function wherever there's that variable. So the first thing I look at with substitution, is there a variable already isolated all by itself? So let's look in this equation. Do you see how y is already by itself? So this makes substitution very easy. So that's why we would choose substitution in something like this. So we take that. That's y is equal to x plus 1. We're substituting it into the other equation wherever there's that variable. Well, there's y in the other equation. So we're going to take that x plus 1, and instead of a y, there's going to be an x plus 1. So we're going to have, I'm going to kind of keep my work nice here. So we have 2x plus, and whenever you make a substitution, it's smart to use parentheses. So plus, and then instead of y, we're writing x plus 1. We're substituting it in. And that's equal to 7. Now check your equation. Is there only one variable? Are we only dealing with x's now? Yes, so this is pretty easy to solve. So from here, we can actually drop off the parentheses. There's nothing being multiplied that we would need to distribute. So what we have is 2x plus 1 is equal to 7. Then from there, 2x plus x is 3x. So 3x plus 1 is equal to 7. So then we'd solve for x algebraically. Subtract 1. So 3x is equal to 6. Divide by 3. So x is equal to 2. We have found the x-coordinate of the intersection of these 2 things. So we found x. Is everybody good so far? Okay, now you can take and plug in that x into either equation to solve for y. I personally am just going to plug it back into this top equation so I can solve for y. So we're now substituting that x equals 2 back into one or the other equation. I'm going to go for y. So y is equal to, instead of x, we know x is 2. So we'll do 2 plus 1. So y is equal to 3. Now, remember, what we're finding is the intersection of these two things here. So you'll write it as a point. It was 2, 3. This is our solution. This is the intersection point of these two lines. Do you see how to do substitution?
Yeah.
I'm going to do one more off the worksheet, number 5. So we have 2x minus y is equal to 7. 3x minus 2y is equal to 10. So it asks us to do it by substitution. The first thing I look for, is there a variable already solved for all by itself that we can substitute in? No. So we're going to have to go ahead and solve for a variable and substitute it into the other function. I always choose to solve for a variable that will give me no fractions. If you do have fractions, you'll be okay, you'll survive, but I just like to not deal with fractions. So everybody look up here. Do you see how y has nothing multiplied to it? So y won't have any fractions. We won't have to divide anything from y, and we won't get fractions. So I'm going to solve for y. So my first step is to just look at this top equation and solve for y. So I would first subtract 2x from both sides, and I'm going to put it in standard form. So we have on the left, negative y is equal to negative 2x, and then it's plus 7. Questions? Y is not isolated yet. We technically have a negative 1 connected. So I'm going to divide both sides by negative 1. So we have y is equal to. As long as you divide both things by negative 1, you can split it up and write it. So negative 2x divided by negative 1 is positive 2x. Positive 7 divided by negative 1 is negative 7. So does everybody see how I didn't break any forbidden rules? Because I still divided both top pieces by the negative. Are we all okay? So now we solve that top equation for y. So now I'm going to go ahead and make my substitution. I'm substituting that into the other equation wherever there's a y. When you make a substitution, use parentheses. So we have 3x minus 2 times, we're substituting in y. Instead of y, we're writing 2x minus 7. That's equal to 10. Then from there, you've got to do some algebra correctly. So we have our 3x. We're going to multiply in negative 2. So negative 2 times 2x is negative 4x. Why am I distributing the negative through? Because then it takes care of all the sign issues. Negative 2 times negative 7 is positive 14. That's equal to 10. Is everybody still following me? Am I going too fast? Are we all okay? So then from there, we'll solve for x. So let's combine our x's. So we have negative x so 3x minus 4x is negative x. Plus 14 is equal to 10. So then we'll subtract 14 from both sides of the equation. Negative x is equal to negative 4. Divide both sides by negative 1. X is equal to 4. So once again, we know our x coordinate of our answer. I'm going to put it up here. It's 4 comma something. So now we're going to substitute the x equals 4 into either equation. I'm going to go ahead and just substitute it back here where I made my substitution because we solved for y right there, so it's easier. But anyway, you can substitute it in anywhere and then solve for y. So I'm going to plug that 4 back in for x up here, so we have y times. So y equals 2 times 4 minus 7. So really we have 8 minus 7, so really we have 1. So y is equal to 1. So the intersection point of those two lines was 4 comma 1. Questions? So that's the xy point where our functions are equal, or what makes this equation true. Okay, do 1 through 10 on the worksheet. Practice substitution for a minute. And then we're going to go on to elimination and then the calculator. If you don't like that method, which honestly that method is one of my favorites just because, but at times it's not the best. Because like let's say you were using substitution, but there was no way you were not going to have fractions. I would not choose substitution in that case. So let's look at problem number 11. So we're going to do this a different method. So now we're going to solve by elimination. So if you're not finished, make sure you're watching and going through this because when you say, I don't know how to do it, it's because you weren't watching. Okay, so solving by elimination. This method you decide I'm going to eliminate x or y. Then you make sure that those x and y, you're going to eliminate x or y first. And then you make sure that those variables, x and x, are exact opposites of each other. So you might have to manipulate one of the functions to make them exact opposites of each other. We'll look at number 11. Now looking at this, we have x plus y is equal to 10, x minus y is equal to 2. I'm going to go ahead and solve for y first, or eliminate y, because aren't they already exact opposites of each other? So now what you're going to do is say, okay, so first of all, I'm eliminating y. So what you're going to do is go ahead and squish those functions together. You're going to add them together. So because these are exact opposites of each other, I'm going to go ahead and add the functions together. So x plus x is 2x. What's y plus negative y? 0. So do you see how y went away? Because they're exact opposites of each other. Now we have plus 0. I'm going to write it so we don't forget what's going on here. And then 10 plus 2. 12. So really we have 2x is equal to 12. Now solving for x algebraically, divide both sides by 2. We get x is equal to 6. Now remember, these are xy points where these lines are intersecting. So we have 6 comma something. So now I'm going to substitute that 6 back into either function to solve for the other variable y. So I'm going to just randomly going to choose to plug it into my top function here. So instead of an x, I have 6 plus y is equal to 10. I substituted it in for x. So solving for y, I subtract 6 from both sides, so y is equal to 4. So 6 comma 4 was the solution. Okay, so we didn't have to manipulate this one at all, so elimination was pretty easy. Let's do one where we have to manipulate it. Number 15. So everybody look with me at number 15. So first of all, remember, you are going to look at a variable and say, I'm going to eliminate it, but they have to be exact opposites of each other. X and 3x, are they exact opposites of each other? No. How about 2y and negative y? Exact opposites? Still no. So we're going to have to manipulate either the top or bottom equation to help us out. So I'm randomly going to go with, okay, I'm going to get y to go away. Is everybody okay with that? I'm going to eliminate y. So let's look. Isn't this positive 2y? So we need this to be negative 2y, right? Get that to be negative 2y, couldn't we multiply it by 2? So if you multiply something by 2, you got to multiply the whole equation by 2. So I'm going to go ahead and do that right here. So 2 times 3x is 6x. 2 times negative y is negative 2y. And then 2 times 9 is 18. Now I have manipulated this bottom equation to fit the elimination of the y's. So now we can go ahead, because we have exact opposites of y's, we can go ahead and squish the function together, add them together. So x plus 6x is 7x. Positive 2y minus 2y is 0. 10 plus 18 is 28. Does everybody see how I did that? So then from there, we really just have 7x is equal to 28. Divide both sides by 7. X is equal to 4. So we know it's 4 comma something. Plug that back into one of the other functions for x to solve for y. So I'll plug it in. I'm randomly choosing right there. So I have 4 plus 2y is equal to 10. Solving for y algebraically. First, I'll subtract 4 from both sides. So we have 2y is equal to 6. Divide by 2. Y is equal to 3. So 4 comma 3 was our answer of where they intersect. Okay, are we all okay? Are you ready to do it by yourself? Okay. So do 11 through 20. So guys, skip over to 11 through 20 and make sure you're practicing elimination. Once again, skip to those so that we can practice these. Once again, this is probably the easiest method as long as you know what you're doing, because your calculator is going to do all the hard work for you, but you have to set it up so your calculator can do it. So even though this last part says, the very bottom says solve by elimination, I'm going to teach you by graphing. So you can cross out elimination, write graphing. So we're going to do number 21. So the first thing to realize here, we are looking for the xy points where these two lines intersect. Now, once again, it's linear because our variables are degree 1. Is everybody okay with that? So now, to be able to graph these guys, since we're solving by graphing, we need each of them in y equals mx plus b form. That's what we've got to do. So let's take this one and write it in y equals mx plus b. So we're solving for y, right? So we add x to both sides. So we have y is equal to x plus 3. I'm going to write it in standard form or graphing form. So I changed the top equation here. Is everybody comfortable with that? Now the bottom one. I'm going to get that in y equals mx plus b form. So I'm going to get y alone, subtract 5x. So we have y is equal to negative 5x plus 9. So y equals negative 5x plus 9. So if we were to graph these on our graphing calculator, we're going to have two lines. They're going to intersect at some point. That is what we're solving for if we were to do it by hand. Let's just use our calculator. So pull up your calculator. So you'll go ahead and go like this. So you'll go into y equals. So you'll type in the first equation, x plus 3. In the second equation, we have negative 5x plus 9. Even if it was fractions, our calculator could do it this way. So negative 5x plus 9. Now, let's hit graph. So it's graphing the first line, it's graphing the second line. We want to know the xy points where they intersect. So you do second trace, go to intersect. Number 5. Hit enter. It's going to say first curve, which means make sure it's on the first line. And notice that's on x plus 3. So we hit enter. So you see it up here. It says it's on x plus 3. Hit enter. It says second curve. It's on negative 5x plus 9. So we're good. Hit enter. It says, do you want me to guess? You do want your calculator to guess. It will guess correctly. Hit enter. As long as you've done your intersection, as long as you've typed in your equations right, your calculator will get it right. So we get the intersections at 1, 4. Isn't that 10 times easier than any of the methods we've done? Mm-hmm. Your window's probably just smaller, so it probably looks a little different, because my window's quite big here. So 1, 4. If you were to actually second trace that, I bet you'd get the same answer. So is everybody good with how to do that? So my answer was 1, 4. Do I need to do another one?
No.
No? We're all good.
Yep.
You don't want me to do number 24?
Actually, yes. Sure. Let's go.
Okay. So once again, first things first. And once again, on the test, I'm going to say solve. You get to do it by your method of choice. I always choose graphing. But you have to have it in graphing form. So solve for y. So I'm going to, 14x plus 2y is equal to 10. So I'm going to get y alone. Subtract 14x. So I have 2y is equal to negative 14x plus 10. I'm going to write it in graphing form, divide by 2. So we have y is equal to, we can split it up and write negative 7x plus 5. Does everybody see how I rewrote the top? Same thing with the second one. Solve for y algebraically, so it's in graphing form, subtract x. Negative 5y is equal to negative x plus 11. Divide by negative 5. So we have y is equal to negative x divided by negative 5 is negative 1/5 x. Am I right? Or am I right? Well, it sure means no. So do you understand how I got positive? Should be positive, so don't disagree with me. Shouldn't it be positive? A negative divided by negative is a positive? Yep. And then isn't x over 5 1/5 x? Do you all understand that? And then positive 11 divided by negative 5 is minus 11/5. So we have y is equal to 1/5 x minus 11/5. Fractions shouldn't scare you because your calculator will be able to do it the exact same. So type it in. You could have actually even typed it in like this into your calculator and it would have been okay. But let's get a little bit more advanced and go this far. So y equals, once again, negative 7x, negative 7x plus 5. Plus 5. And 1/5 x. So 1 divided by 5x minus 11 divided by 5. I hit graph. Then I'm going to do second trace. Find the intersection. So you might be asking yourself, so why do we even need to know the others? So second trace, and it's because, let's say you did this and you did it with your calculator and you got a decimal and I said, write the answer as fractions. You'd have to go back and do it by hand, right? Unless you knew what the decimal changed to a fraction as. Does everybody understand what I'm saying? Okay. So first curve, it's on this line, I hit enter. Second curve, it's on this line, I hit enter again. Intersects at 1, -2. Sorry, geez, 1, -4. So, ready, set, go. Finish the front page of the worksheet. That's what's due by tomorrow. You have 20 minutes to finish it.
That's it.